Let's hear about a new programmable robot system on the K-12 Engineering Education Podcast. Today's guest believes that robots are our future, and he says that customizing robots can teach us about algorithms, physics, artificial intelligence, art and design, and many other subjects. That's why he's developed his new line of robots. I'm Pius Wong. My guest is Ian Bernstein, engineer and founder of Misty Robotics based in Boulder, Colorado. Ian spoke to me about his new robot, Misty II. Listen to our talk next. All right, so Ian, thank you so much for taking some time out from your day to talk to me.
No problem.
You've got a new robot out there, a new educational robot called Misty II. Wondering if you could just explain a little bit or tell me a bit about Misty II.
Yeah, so Misty II is coming out in December. Misty is a robot. She's about 18 inches tall. You can get a white one or a black one. Her design, she has tracks to drive around. She has arms, a head, a visor, and a face. She's was really inspired by, we probably went through 150 different iterations on the design, but a lot of her design was inspired by sort of like WALL-E and Eva and Baymax and sort of cute robots like that. And she's designed to be a personal robot for the home, but also very programmable. So that anybody from being a kid to a professional programmer can get into robotics, having not known anything previously about robots, but easily get into robots and really start to figure out how robots can be used in homes and offices.
Okay, because you yourself, you're not new to robotics. And it sounds like this is the new thing, that you're making a robot that people can program, that they can change. Is that right?
Yeah. So I got into robotics when I was 12. Is when I first built my first robot. In 2010, that's basically all I did through middle and high school is built robots. And after in college, I had an internship at a robotics company. And then in 2010, started a company called Sphero, where we made this robotic ball that was connected to your smartphone. And it was kind of a happy accident around 2012 that we found that it worked. That one also worked really well for education and teaching, programming and engineering and all kinds of different, and art as well. So it's more like the STEAM. And then a year ago, we spun out this new company to do a more advanced robot. So Misty is kind of if you look at sort of STEM education, it would be the next step beyond a Sphero Spark or a Lego Mindstorms, where you can really start to do more even useful things for people, but in fun as well. But it's kind of that next step beyond those types of products.
Yeah, you mentioned some of the other products that basically are your competition, like Lego Mindstorms is the big one. I think a lot of engineering teachers, robotics teachers know about that. What is different about Misty compared to, for example, Lego Mindstorms?
So what we found, one of the things, for instance, that we found with Sphero is that, teachers have a limited amount of time in their class period that they need to convey some different things. So Sphero provided a lot of creativity, but there wasn't 500 pieces and things to lose in different parts, and then you'd have to disassemble your project after. So Misty can be extended by hardware, so you can 3D print your own accessories and stuff like that. But it is a built robot. It's more about sort of the software side. But you can do things like face recognition. She can map your space, so she can actually navigate from room to room or around a classroom. She can listen, so voice recognition and voice interaction. She has a really good speaker system. A personality, so people can write their own personalities for Misty.
Yeah, because to be clear, your face is actually like an LCD screen or something. Is that what it is?
It is, and it's okay. So it is a LCD screen face, but it's set behind this clear visor, so it gives it depth. Like it doesn't necessarily feel like a screen face.
So you can program facial expressions and get into that if you wanted to.
Yeah, exactly.
Okay.
And the idea is to try to get, our big vision is to get robots, doing more useful things for us, taking all those sort of mundane tasks out of our lives. So getting robots that can actually do useful things, waking you up in the morning and following you around as you're getting ready for work or school or whatever you're doing that day, watching your pets, being your little security bot when you're not at home, that sort of thing. And then, of course, you can add on different things to Misty as well if you want to be creative around that side and add a gripper arm or add other sensors to it.
So Misty II has all of those capabilities that you mentioned, being that security robot and some kind of, sensor robot. It can do all that stuff.
Yeah, it certainly has the capabilities, but right now it's up to the community of people to sort of write these skills. So we're providing a platform and making it easy. So abstracting a lot of these, which in the past have been very, very, very difficult, hard engineering problems, like mapping for a robot, and turning that into something that a kid could figure out. Like hit one button and Misty will automatically drive around and generate that map. And then you get like a floor plan of your space on your computer or your mobile device. And then you can just tap on it to get Misty to navigate to that spot or get the coordinates of that spot, which then people can, somebody could use in their program that they're writing. So just taking these really advanced things that haven't really been obtainable. If you're a PhD in robotics or something, it makes sense, or a software engineer, but bringing this stuff to the level that, again, like a kid can have access to it.
Right. Yeah. For example, Lego Mindstorms are definitely not going to have a button press map creation function in it. I don't think they do voice recognition necessarily either. You used that word skill, like you wanted to make it so that Misty was open source, it sounds like, where people can contribute their skills to the robot. Is that something you think you want to see? You want educators to have their students create skills and upload it to some collective repository that other people can use?
Yeah, exactly. So we have a community right now of people that are, as we're just starting to get some of these robots out, it's community.mistyrobotics.com. And people are already starting to share some of the skills that they're writing. Eventually, we'll have sort of that same app store experience that you download apps onto your phone. You'll have that same skill store experience where you can easily load skills onto your Misty. So people, say kids can try out different things that other people are writing. They can, hopefully a lot of these skills will be open sourced and shared so that they can download the code and add on to it, modify it, use it as a reference for their own projects that they're working on. Ultimately, really progress and progress robotics and really learn about robotics, because there's a lot of great things about robotics for education, right? Because it encompasses so many different disciplines, from art to software engineering to mechanical to electrical to psychology and all kinds of different things.
Totally. And so from what I see of Misty, I mean, it's got more intelligence, or the more capability for intelligence. You've kind of abstracted a lot of things out to make it easier to program. It's probably, like you said, less focused on the physical design of things. So let's talk about that programming then. How do kids program it? Like, what's the language or languages, and what would that look like?
So we're starting at the very base level. Right now it's in Blockly, which is sort of an equivalent branch of Scratch, which a lot of educators and kids are already familiar with.
Right.
So you can program her without writing a single line of code and just dragging some blocks into a workspace and hitting run. So that's at the base level. Her textual programming language is JavaScript. So once you sort of graduate from that Blockly Scratch environment, you can also generate JavaScript code to see, what the blocks are actually generating.
Yeah.
And then you can write this JavaScript code on your device or send that code to the robot to run autonomously.
That's pretty cool. Do you imagine, or have you already seen classes using the robot in that way? They use it to teach programming, either block programming or JavaScript.
So we're just starting to ship. So we haven't had, well, other than events like we have sort of these Robothon hackathons at our office where we've seen kids program it there. We haven't seen Misty in classrooms yet, just because we haven't shipped.
Sure.
But of course, on the Sphero side, where 6 of us on the team worked for many, many years, and I helped co-found Sphero. Sphero is in probably 10, 15,000 schools worldwide now. So a lot of experience seeing how kids use that. And Sphero is the same with a block-based language to program it, and then JavaScript as well.
That's cool. And so since you have that experience with Sphero, with educators, I'm sure that you already know that like giving teachers a piece of educational technology sometimes doesn't work alone. I'm wondering what educational support do you think you can provide to teachers who want to have Misty? Is there any curriculum, or I know you mentioned the community that's available. That seems great. What else do you have available for educators?
So a lot of it's just sort of one-on-one support and working with them and talking to teachers. We found one of the best things that worked at Sphero, and I think we're going to do here at Misty as well, is just creating that community, creating a place that teachers can share ideas, share the lessons that they're coming up with, because a lot of them were like, we quickly discovered that educators are a lot better at educating than we are. So just creating a place where where this community can come together and people can share ideas was one of the biggest things. And again, just being able to support them one-on-one and have these, personal discussions and conversations was really helpful.
This is really early then. Like you're taking the ideas from educators who are coming on board, it sounds like.
Yeah, absolutely. Absolutely.
How can teachers get their hands on it firsthand? Because I think a lot of teachers would be super interested in this, but they don't want to just commit to buying a bunch of robots right away. Is there any way they can see demos or play with it a little bit before they decide they want to order it?
We're exploring different, and we do have some educational discounts, but we are exploring ways that, and we love ideas from people as well, but how, exploring ways that people can, like you said, can try it out or see a demo or something. Either maybe it's some different online like webinars and stuff that are more interactive, so teachers and educators can ask questions that we can answer and actually maybe demo certain things on video for people. But yeah, we're totally open to different ideas and models that might work
right
for educators.
Yeah, I'm sure the computer science teacher conventions and the engineering education conventions would be great places. I always am a fan of South by Southwest since I'm from Austin. But then, so the biggest hurdle, I would say, that educators would have in buying educational technology, including these robots, Lego Mindstorms, whatever it is getting through their administrators, their principals, and the people who are spending the money. What's your pitch to them? Like, administrators care about how much it costs, how much kids are going to learn. What do you tell principals and those people about your robot?
Well, I mean, I think robots are going to be really important. Like I have this story that a couple of years ago, I was thinking about how the computer industry got started as we're thinking about robots today, and I ended up calling my dad because when I was 5, he bought this Apple IIe from a friend of his. And thinking back a couple of years ago, I was like, wow, this, we didn't grow up with a lot of money. And it was probably the largest purchase financially that my family ever made that I can think of growing up.
$1,000, or how much was it back then? I'm trying to remember.
Yeah, I think used it was about $1,000 at the time that he bought it, which is how many in today's dollars, right? And I asked him, he's not like a tech gadget person. He's a professional musician. So I asked him, like, why did he buy it? Like, that seemed kind of crazy thinking back. And he said, well, I bought it for you. Like I saw computers and I thought they might be important in the future, and I wanted you to know about them. And it obviously worked out for me. And I've told this story to several people, and I've heard back like, wow, like that's actually what my family did. And here I am today, like at a tech company or a founder of a tech company or an engineer, right? And thinking about where, a 5-year-old today, I think we're in that same spot with robotics. And if you think, 15, 20 years from now, when these kids who are 5 today are graduating college and going into the workforce, like robots are going to be so important. So, what would I say? It's a little bit more forward thinking, but these robots, and not just sort of toy robots, but actually working with robots that can do useful things, that have these levels of sensors and having this understanding is really important. Really important today for kids and adults as well, right? Because that's where we're all going, right? Just like computers are today, the more proficient we are in computers, the better it is for. It makes it a lot easier to get a job, right? So
right, it's kind of
be the same for robots in the future.
It sounds like an investment of sorts,
right?
Schools and educators can be the judge of whether that investment is right for them. Right now, the Misty II robot is listed as $1,999 for one unit. Ian explained that educators get discount offers, getting a couple $100s off each robot depending on how many robots a school buys. Details on the educator offer are linked in the show notes. Now, back to the talk. What age range do you expect to target with Misty? I know that you've got lots of capabilities with the voice recognition and the mapping and all these different actuators. So is it more for older kids, or what do you think?
I would say anywhere from 5 and up.
Oh,
surprisingly, wow. I mean, I've seen kids 4 and 5 with Sphero programming pretty complicated stuff with Sphero at that age in Blockly. So I which kind of blows my mind, but like,
cool. No, I get to see that, and I don't doubt you because it's Blockly, and I've seen similar things with other robots.
Right. So I would say it starts around there, and then of course, high school to university, because you can go so far with this robot, and like I was saying, you can really go beyond a lot of the more educational robots that are out there. You can basically go as far as you want. So really strong in sort of high school and college as well.
It sounds like some teachers, I mean, teachers might want to have some kind of background a little bit in programming. Like, could they just go cold and try to figure out how to use Misty? What do you recommend?
I think because of the block-based programming language, I think anybody, and I think that's one of the reasons that Sphero is so successful, is that you really can just sort of jump right in, even if you don't have a strong engineering background. And because the product, not just from the programming perspective, but just because the product is so simple to use, you just flip a switch and it comes on. Misty can charge herself, that sort of stuff. You don't really have to know anything about robots or software engineering or anything to be able to build some lessons around it. And it doesn't even have to be programming either. Like I was mentioning, we release all the CAD models for the arms of Misty. There's some different magnetic attachments on the head. There's a magnetic backpack, which has an Arduino in it. If you know what an Arduino is, it's a little electronic board that's quite easy to program, and there's probably hundreds of thousands of projects online with sample code. So you can basically plug your Arduino project into the back of Misty as well. So there's lots of different pieces of Misty that you can work with. It doesn't necessarily even have to be the programming piece.
Okay. You talked about releasing a lot of the design files or CAD files to the public. And then you also talked about sharing code in the community. So this open source philosophy seems to be pretty important to you.
So it's not 100% open source, but it's enough that you can be very creative and almost tweak everything about the product, but maybe, some of the hard, like really hard SLAM algorithms for doing mapping and navigation and stuff like that. Maybe that's not all that source code isn't open sourced, but you'd be able to sort of have lots of hooks into that to do pretty much whatever you want.
Okay.
So it's almost 100% open source without being open source, if that makes sense.
Why make all this available to people anyway?
Yeah, I mean, part of our model is, I mean, we want to do something big and get robots in more people's homes. And I mean, ultimately, we want robots to like fold our laundry and cook our food and do all this stuff, like the things that are super time consuming for us that we should be outside like doing something or spending time with our families than doing laundry. But if you think about other technologies, for instance, your smartphone, most of the apps, almost all of the apps on your phone aren't written by Apple or Google, right? They're written by third-party developers. So it's the same way. Like there's no way that Apple or Google, even with hundreds of thousands of employees, could build all of the different things that people would want and have the creativity and innovation to build all those different apps, right? It's impossible. So it's the same way. Like we want people who are, all different kinds of backgrounds and having so much creativity and innovation, building the different skills for Misty. So that's one of the reasons we wanted to open up. People will come up with stuff that we could never even think of. And allow those people to share it with other people.
So you're building not just a product, you want to build a platform where people can learn or do whatever they want with it. I think I get it.
Yep.
Okay.
Yeah, exactly.
You kind of talked about this already, but like you have an engineering background yourself. That's kind of how you got into this. You've been into robotics since you were a kid, you said. What is so appealing about it?
I think a lot of it is that creativity. Like my dad bought me that computer when I was 5. I discovered this language called Logo, or it's this little turtle that you would program to draw different shapes on the screen. And then I went on to BASIC. And when I was 12, I was homeschooled at the time, and my dad, we learned about this robotics competition that was going to be happening a couple hours away from where I grew up in New Mexico, and decided to check it out the first day. Walked in and they were like, "Hey, are you here for the workshop?" And we didn't even know about that. Ended up going right into this workshop and built my first robot, and I was just totally hooked because I don't know, I really like being hands-on, and I've always liked sort of the artistic piece of it, like because there is an art to a lot of robotics, right? The form factor and things like that, making it look good, and usually a lot of times things that look good also function well. But then sort of back end engineering and problem solving and how it encompasses just a broad set of skills, the mechanical piece of it, the electrical piece of it, the firmware, the high level software, and then being able to put all these pieces together. I don't know. It's so much fun to me.
Yeah. It sounds almost by chance though. Like if you never took that workshop, would you have run into robotics?
I don't know. It's an interesting question. And even ever since I was can remember, I always had this cardboard box. I was probably 3 years old or something. And I would just take things apart, like broken electronics and cameras and stuff. And I would try to fix them. Of course I couldn't. I would just take them apart. But I was always sort of had that really hands-on mindset. But yeah, I don't know if I hadn't have discovered robotics then, I feel like I must have would have discovered it at some point.
Yeah, no, I'm asking because engineering teachers probably totally agree with you about the value of robotics and the creativity of it and the connection to art. They agree. And I guess the problem always is, how do you get more kids to see the same thing? And it's funny when talking to engineers like you, because a lot of the times it is kind of this one-off event that happens that kind of brings you into it. I'm wondering if you have any other ideas. You've worked with a lot of other engineers. I'm curious if you've seen any patterns or tips, four tips in how to attract more people into not just robotics, but the creative engineering fields.
I mean, obviously, one is exposure, right? If I wasn't exposed to the robots, then, like you said, maybe I wouldn't have found it, right? So getting them out there, and then I think just facilitating the different pieces of it. So there's a lot of stuff around Sphero on the art side, right? Like there's a cover that you can get. I mean, well, Sphero is waterproof, so you can drive Sphero through paint. And you can write either just drive it manually, or you could write a program to do a pattern and draw something in paint on like a piece of paper on the floor. So I think it's, part of it, especially with these robots, maybe not just going straight into the programming piece, but showing kids that there's so many different aspects, like 3D printing, like a different arm. Like I made a little gripper arm, and I made another one that has a little laser pointer in it to like play with your pet, or even like decorating Misty. So one of our engineers is really into LED lighting. So he made a LED mohawk for Misty, which is kind of like, it's just something that's really fun in LEDs, and it's a mohawk, but it teaches, but on the backside, it's sort of learning through play, right?
What are some of the biggest challenges you see when dealing with the field? And I ask this because I know firsthand a lot of students and teachers can get frustrated when doing robotics. Sometimes they just think it's too much or it's too hard or something. What do you face what do you think is challenging about robotics, and how do you get over that?
I mean, a lot of it is making it really easy, and it's not easy to make it easy, right?
Okay, yeah. So your job is to make programming easy, and that itself is a challenge. Okay.
Right, and abstracting a lot of these concepts, like making it so that you can just hit one button and Misty will generate a map of your space. It's a lot easier to build a robot for roboticists or for an engineer that has a lot of experience in that space. Getting it so that a kid can sit down and do something really advanced simply is kind of that, that last 10% that takes 99% of the effort. So I would say that's really, it's a lot of work, and it's challenging.
Do you ever get
to figure out ways of abstracting that stuff?
Do you get frustrated in trying to solve these problems?
Oh, there are all kinds of frustrations.
No, okay, that's good to hear. Sometimes some kids, some teachers may think that engineers don't get frustrated. They just know all the answer. I'm assuming you did not build Misty in one go. You said there was many iterations through Misty.
Yeah, we were going through iterations. Yeah, I was at the office until 2:30 a.m. last night working on some stuff.
Oh, gosh. Well, thanks for talking this morning.
No worries. But it's fun.
Good.
Fun challenges.
It's finding that balance of being just challenging enough where you have fun and it's not debilitating. How can we find out more about you and about Misty II?
I would say just through our website is probably the easiest, at mistyrobotics.com. That's MISTY. Yeah, and there's lots of stuff online. If you search for, just do a Google search for Misty Robotics or Ian Bernstein. There's a lot more information on sort of my background and how I got into this stuff, and Sphero and Misty.
And Ian, that community that you mentioned earlier, is that something that's open to the public as well, or do you kind of already have to be a customer?
No, anybody that's interested in AI or computers or robots or whatever is definitely welcome to come hang out and have discussions with us. We're all active on there. Our engineers are active on there, so you can ask questions at any level of detail, from high level down to deep engineering questions, if that's what you're curious about. And yeah, we just want to create a place where we can all get together and have fun and work on robots and do cool stuff.
Very cool. I hope that your message speaks to a lot of educators, a lot of students. I know that you've got a bunch of videos on there as well. You got a YouTube channel, so people can find you however they want to. And Ian, I just want to say thanks again for taking some time out to talk to me, and to any educators or engineers who are listening to this. And good luck with your campaign. I hope that it keeps on developing.
Thank you. Really appreciate it.
That was Ian Bernstein of Misty Robotics. For more on Misty II and Misty Robotics, or for links to background information on anything else you heard here, check this episode's show notes or visit the podcast website, k12engineering.net. Please take a minute and leave the podcast a rating and review on Apple Podcasts, Stitcher, or however you're listening. Share it with your colleagues, tweet the show, follow us on Facebook. All of this helps me continue what I'm doing. And finally, a huge thank you to my Patreon supporters helping me cover my costs. You make this show possible. If you aren't yet supporting the podcast, consider pledging $1 on Patreon. Go online to patreon.com/PiosLabs. Our closing music is from the song Yes and by Steve Combs, used under a Creative Commons Attribution license. The K-12 Engineering Education Podcast is a production of my independent studio, Pios Labs, in Austin, Texas. Thank you for listening, and please listen again. Hey everyone, it's Pius again with a few post-show notes. Rachel and I have submitted to South by Southwest again 2019, meaning if you help us get there, we can go to South by Southwest, the conference here in Austin, Texas, and talk about a whole bunch of cool ideas. So what I would love for you to do is right now, if you're at your computer on your phone, go to the voting website. It's panelpicker.sxsw.com. That's panelpicker.sxsw.com, and register if you haven't already registered. And search for my name, Pius, Pius, and our 3 proposals will pop up. And click the little up arrow to vote them up. If you want to know a little more about what we were proposing, Rachel and I wanted to again have the successful podcasting meetup. Last year, it was awesome. We also want to live record people's thoughts about how digital media is going to play a role in education in the future. So there's that. The other proposals that we submitted were both to South by Southwest EDU and Big South by Southwest proper. Some of our colleagues, some of our friends offered to talk about their experiences as teachers who are also now working in the tech industry with startups or with major software companies. And we want to kind of reveal why teachers may be leaving their field or reducing their hours in their field to pursue some of these technology and engineering industries. I think educators need to hear that to learn about how to retain good teachers. We also think that company people and corporate people and investors need to hear this because they need to stop devaluing teachers. They need to look at the great stuff that teachers have to offer in the classroom and out of the classroom if they so choose. So if you want to vote that up for us, we would love that. Again, go to panelpicker.sxsw.com, search for Pius, P-I-U-S, or just browse all the cool sessions, and we would love to have your vote. Thanks.